Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over some more examples for adding rational expressions. In these examples we'll have a bit of a different time solving them because in the denominators here we've got two sets of quadratics instead of two monomials. So here we're going to have to actually factor out each of these quadratics in order to figure out what to multiply each fraction by. So first we'll start off by factoring this one. Remember, we need to find two factors of 2 that add up to positive 3. So the factors of 2 are just 1 and 2, which if we add those is equal to 3. So we'll take that 1 and 2 and split this quadratic into the factors just like you have been. So we'll have x plus 1 and x plus 2. Now we'll factor this one. Remember again, factors of 6 that add up to positive 5. So the factors of 6 are 1 and 6, and 2 and 3. 1 and 6 add up to 7, so not that one, but 2 and 3 equal 5. So these are our two numbers again. Remember, we're going to have to keep that plus from there, and then we'll have 1 over x plus 2 and x plus 3. So now we have to pick which factors to take from each of these denominators and multiply them over to make them the same denominator. So here we can see that each of these terms share an x plus 2, so we don't really have to bother with that one. Instead, we're going to look mainly at this x plus 1 and the x plus 3. So in order to get these denominators to be the same, we'll have to multiply the right term by x plus 1 over x plus 1, and then the left term by x plus 3 over x plus 3. So if we do that, multiply across on the top and bottom, we get x plus 3 over x plus 1, x plus 2 times x plus 3. And now we'll multiply across over here on the top and the bottom. So we get x plus 1 on top, and then the same denominator, x plus 1, x plus 2, and x plus 3. So now that the denominators are the same, we can multiply or add the numerators over. So here we'll just combine like terms. We've got two x's, so we'll have 2x, and then 3 plus 1 is 4. And that's still over all of this bottom stuff. Now, if you're paying attention, we've got a 2 and a 4. So on top we can factor out a 2. So we'll move this over, get x plus 2 on the inside, all over x plus 1, x plus 2, and x plus 3. And now our final step, since we have an x plus 2 on the top and the bottom, these will cancel each other out and leave us with just 2 over x plus 1 and x plus 3. So this is the final answer for this example. Now, moving on to the second example. This one's a little bit more complicated because we've got numbers other than 1 in the numerator, but that won't really become a factor until near the end. So once again, we'll just factor out each of these quadratics. So we need two factors of negative 2 that add to be negative 1. And remember, since that middle term is negative, the bigger number in the factor set will be negative. So we've got 1 and negative 2. So if we add these together, that ends up being equal to negative 1. So we'll pick those two numbers for our factors. So we have to keep that 2 in the numerator, and then we'll split this into its factors, x plus 1 and x minus 2. And we'll do the same for this one. So factors of 3 that add up to 4. So the factors of 3 are just 1 and 3, and that's equal to 4. So remember, keep that 5 from the top, and then we're going to split it into x plus 1 and x plus 3. So now, just like the last example, we're going to have to figure out which of these factors from each term to pick. So since they each share an x plus 1, we can ignore that. But they don't share an x minus 2 or an x plus 3. So we'll multiply the right side by x minus 2 over x minus 2, and the left side by x plus 3 over x plus 3. Sorry about that. Now we'll just multiply across the top and the bottom, and we get 2x plus 6 on the top over x plus 1, x minus 2, and x plus 3. Now we'll multiply across on the top and the bottom, and we get 5x minus 10 over the same denominator, x plus 1, x minus 2, and x plus 3. So now we can add the tops together and combine like terms. So we've got 2x plus 5x is 7x, and then a positive 6 plus a negative 10, which is really 6 minus 10, or negative 4. And then that's all still going to be over this denominator, x minus 2 and x plus 3. And since this in the top is already factored out as much as it can be, this is our final answer for this example. So the general process is kind of the same as the last video, but we just have to figure out the factors of the denominator first and decide which ones to pick. That's about it. Thank you for watching.